Hey students, this is Mrs. Tran-Bloom. Okay, so we are studying still the quadratic function, but this time we are going to study the vertex form of it, okay? So the vertex form, sometimes if you hear me say the word HK form, that's exactly the same thing. It is f of x equals a times this quantity x minus h raised to the second power, because it's quadratic, is always going to be raised to the second power plus k. Now, if you guys remember, this is very similar to your absolute value function, okay? And remember, in the absolute value function, it was y equals or f of x. Remember, that's exactly the same. And then we have the a in the front. That means it was your slope, and then it was x minus h, okay? So that is going to change your vertex, and then plus k. Now, I do also want to bring you back to another form. This is a linear form, and this linear form was in the point slope, okay? So point slope. So linear point slope. Now, if you remember, it was y minus y1 equals the slope times x minus x1. Now, one would say, well, how is that the same as my HK form? Well, if you can see that if we were to add y1 to both sides like this is going to look more like y equals the slope times x minus x1 and then plus the y1 at the end. Now, can you guys see that the x1 and y1, that's the same thing as hn and k, and then the slope is really your a? Yep, those are all exactly the same, okay? Now, let's go over your function really quickly. The first one is the parent function, which, guys, we did this already in the last section, okay? So the parent function is just simply y equals x squared. So we are going to pick 5 inputs. And guys, we don't have to pick -2, -1, 0, 1, or 2. You can technically pick any value that you want to pick, as long as something that you can do fast. But we always pick the easiest 5. So from our recollection, if you have a -2 in the quantity square, that should be 4. -1 in the quantity square, this will be 1. 0 square is 0. 1 square is 1. Remember, we're supposed to plug it back in there. And then 2 squares is 4. We can easily plot this out. -2 up 4, -1 up 1. Remember, it's supposed to make a U shape, not a V, okay? If it looks like a V, fix it so it looks more like a U. So always round out this vertex here like that, okay? And then go as far as your grid will allow you to go. Sometimes it's okay to go off the grid a little bit to make a better graph. Now, the parent function, just like our notes from last time, it's pretty simple. The vertex is at 0, 0. The axis of symmetry is going to be at x equals to 0, because this is the line where it has a left and right symmetry. And then it opens upward, okay? X-intercept happens to be at the origin, so that's going to be 0, 0, so it's the y-intercept. The domain is always all real. The range is y is bigger than or equal to 0. Or if you like interval notation, that's okay to do. You can pick one or the other. It is definitely a function. It is not a one-to-one. The rate of change, since this is not a line, we're going to say it varies. We do have an increasing and decreasing. Increasing is going to be on the right side, so that's going to be from 0 to infinity. Decreasing is going to be on the left side, so that's going to be from -infinity to 0. It has a minimum value because that's the lowest point here. So we're going to circle, we're going to circle minimum. And then we're going to state what the y value is. So the minimum value is 0. And then, is it continuous? Yes, it is. We can graph the entire piece without lifting your pencil. So yes. Okay, guys, so the parent function is a function that has no transformations whatsoever, right? Using this vertex form, we can see how many transformation that a quadratic function can contain. Now, we use decimals already, okay? So if you were absent, make sure you speak to your teacher about this decimal activity. State what happens to the parent function. We apply the following transformation. Write down, oops, looks like I have two A's here. Looks like, write down a short description. So from your transformation decimals activity, this is all for you to fill out, okay? So I would like for you to write something that will help you remember how to execute your A, H, and K form. Now, if you need to check your work, you can speak to one of your teachers, okay? Or you can look at the key, the note outline key on the weekly agenda. But this is not going to get filled out. You're supposed to fill this out all by yourself. Now, we're going to use your transformations, okay, to finish the rest. So example 2 to 4 says state the A, the H, and the K, and the transformation. Then graph each function by making at least 5 points. So we're going to say, okay, well, remember, your vertex form is y equals A times x minus h squared plus k. Well, as you can see, guys, this, I don't see anything behind the x squared. So if we were to write it like this, it's going to be half x minus 0 square plus 0. So the h and the k are both going to be 0, but the a is going to be a half. Okay, so half, 0, and 0. Well, let's start with the parent function table. Okay, the parent function is always going to be y equals x squared, and then we'll fill out the transformation in just a second. You should not, okay, memorize the parent table, because by the end of the year, students, your brain's gonna explode if you try to memorize everything. Try to see where these values coming from. So if you plug in the values, we should be able to get 4, 1, 0, 1n, and 4. And we're going to use this to transform it. Now let's talk about the transformation. Since we only have one value here, that's a half. So we have one transformation, okay? So the transformation for that is going to be a vertical compression factor of half. So guys, since we only have one transformation, and this one says vertical, that means it's a change in y. So that half that we see in the front for the a, guys, we're going to shrink everything on the y. So we're going to take half, because that's what a value is, and we're going to time all the y values, right? Now, the x, we don't have anything that's going to change or transform the x. X will stay. So this right here, we're going to copy it and make it right there. So whatever that is exactly the same. So -2, -1, 0, 1, and 2. Now, what we need to do is, whatever the y from your parent, guys, whatever y we have chosen, we now need to compress it by a half. So that would go 4 times 2. Remember, this needs to go here, okay? Whatever y we have on the parent, it needs to multiply by half. So half of 4 is 2. Half times 1 is 1 over 2, or 0.5. Half times 0 is going to be 0. Half times 1 is back to half. Half times 4 is now 2. So you're going to see that your y value are now shrunk by a half, okay? So -2 is now up 2. Instead of before, -2 was 4, right? -1 is now a half, so it's going to look like this. And 0 is still at 0. And 1 is now a half, so it's right there. And 2 is now back up to 2. So if we compare these dots, students, with the parent, you're going to see that it's going to be wider, because we are shrinking it. We're smushing it down and making it by a half. So your graph is going to look wider because everything just got compressed by a half on the y. Okay. Now let's try to fill out the chart. Oh no, we don't have a chart for this one, so that's okay. We can do the charts later. All right, let's do 3. Y equals 1/2 in the front times the quantity of x minus 6 to a second power. Remember, there's no k here. So if there's no k, that means k is going to be 0. So if we see this, think about your vertex form. It's going to be a times x minus h square plus k. This is always going to be your vertex form. Now, remember, the vertex, it's, what did I do there? It looks like I hit a button. The vertex form, students, it's always going to be an h comma k, just like your absolute value function. So even though there's a negative here, but your vertex is going to be a positive, okay? So when we see this, there's a -6, but we take a 6. Now the a is going to be in the front, so that's going to be a half. So currently we have two values, a and h. So we're going to have two transformations. The a being a half, it's a vertical compression factor of half. Okay, so that means a vertical means we are going to change the y values. Now h is 6. 6 is positive. So we are going to horizontally shifting to the right because it's positive. Shifting to the right. And I want you to spell out how many units. 6 units. Okay. So we are going to, again, start with the parent, which is going to always be y equals x squared. This equation, student, for the quadratic parent doesn't ever change. The y values and the x values, if you pick x, whatever x you pick, I just need 5, okay? It doesn't have to be these 5, but whatever you pick, just pick them. And then quickly get your y's. And then, hey, the more times you make these tables, the quicker it's going to be. First transformation is a vertical compression. Okay, it was a half. So we are going to take a half and times the y. Now you have the word horizontal. That's an x change. And you have a 6. And so that means we are going to take whatever x from the parent and we would add 6 because we're going to shift it to the right. So what I would like for you guys to do right now is take all of these and add 6 to get our new table. This is called the transformation table. So -2 plus 6 is 4. -1 plus 6 is 5. 0 plus 6 is 6. 1 plus 6 is 7. 2 plus 6 is going to be 8. Then now take all the y's here and then compress it by a half, okay? So 4, half of 4 is 2. Half of 1 is a half. Half of 0 is still 0. Half times 1 is a half. Half times 4 is 2. So now let's plot. 4, I'm going to go right 4 and up 2. Go 5 and now a half y. 6 is now 0. 7 is back to a half value of y. And 8 is going to go back up to 2. So again, make sure we round out the bottom. Okay. So the only difference, students, from the one above and this current one is we move to the right 6 units. Now look at the asymptotes. I'm sorry. Look at the axis of symmetry. Here's the axis of symmetry here. Isn't that 6 units from here to here? And that's what the h value is going to do. It's either going to go left or right. Okay, right if it's positive, left if it's negative. Now let's put it all together now. This one, we will have both a, h, and k. So the a, again, is a half. Remember, if you see a -6, you're going to take a 6. And then the outside, if it's positive 3, we will keep it as 3. You will have 3 transformations. Vertically compressed by factor of half, horizontally shifting right by 6, and then since k is positive, vertically moving up, we're shifting up by 3. All right, so we are going to quickly do the parent. Y equals x squared. By now, guys, we are going to pick these 5. And no, it's not required to pick these 5. You just need to pick your 5 if you want to pick something different. 4, 1, 0, 1, 4. Transformation, first one says vertically compressed by a half. Vertical means the y will change, so we're going to take the factor of half multiplied by y. Next, this is horizontally shifting right by 6. Right means positive, so I'm going to add 6. And then the next one says vertically moving up. Moving up means I'm going to add 3. So just like the other ones, we're going to take all the parents' x's and add 6. Okay, and then that's going to give us -2 plus 6 is 4. -1 plus 6 is 5. 0 plus 6 is 6. 1 plus 6 is 7. 2 plus 6 is 8. Then we will take all the parent y's here and multiply by half and then add 3. So 4 times a half, guys, is going to be 2. 2 plus 3 is 5. 1 times a half is half. Half plus 3 is 3.5 or 3.5, okay? 0, this is our next y. 0 times a half is 0. 0 plus 3 is 3. Next is 1, but that's already done, so that's the same thing as 3.5, okay? And then this 4 value is the same as this one, so as you know, it's a U shape, so it should be symmetrical. So now we have 5 value from the transformation table. 4 up 5, that's our first dot. 5 is now up 1, 2, 3, 3.5. 6 up 3, 1, 2, 3. 7 is now 3.5. And then 8 is here. Now, not only that we shifted right because of the 6, okay, we now also have moved up. Look at this. Okay, your vertex has moved up in addition to moving to the right. So that's why the k value, it's either up or down. Up if it's positive and down is negative. Example 5 and 6 says graph each function by making at least 5 points and answer the requested characteristics. Okay, so 5 says y equals -2 times the quantity of x plus 5 squared plus 8. So students, -2, that's going to be your a. This is a positive 5, so your h is going to be a -5. 8 is going to be your k. Okay, so notice how the k does not change the sign. Parent table, always start with that because that's always going to be the easiest. So here's x, here's y. Now in your homework, if you make one parent table, then that you can use that for the rest of the questions. But if you need the practice, then make a parent table for each and every question, right? Because by the time you guys want to take your quiz or your test, you should have all of this worked out really fast, like that. So students, since your h and your k is your vertex, that's going to be -5, 8. Axis of symmetry, it's always the h value, so immediately x equals to -5. It says make 5 points on our transformation, so we are going to state the transformation so we can use it. Now this one's really tricky and I want you to make sure you pay attention, okay? This -2 right here, whoa, that I need to make that a little bit thinner. This -2 right here, students, is technically a -1 times a +2. So this itself has 2 transformations. I'm going to use all of the space here. So currently this problem has 4 transformations. The negative in the front is a vertical reflection. Sometimes you will also hear reflect over the x-axis. So either one of those would mean the same thing. Now then the 2, that's a bigger than 1, so that's going to have a vertical stretch, okay? Vertical stretch. And we want to say factor of 2. Then your h being -5, that's going to be a left 5 units, okay? You may also write horizontally shifting left, by 5 units. The k being a positive 8 students, that's going to be up 8 units. Okay, so using those transformation, we will have a vertical reflection, that's going to be a change in y, a vertical stretch, that's also a change in y, a left and the right, that's an x change, up, it's also a change in y. So we have 3 transformation for y. Okay, so let's figure out where that's going to go. So the -2, both of those are vertical, so we are going to take -2 times a y. The 8, it's up, so that means it's also changing in y, so we will add the y. We have a vertical, left 5 units. Left means minus, okay, so we're going to go x minus 5, just like that. So all of the x's here will now be changed in our transformation table right here. So let's move it. Ready? -2 minus 5 is now a -7. -1 minus 5 is -6. 0 minus 5 is -5. 1 minus 5 is -4. 2 minus 5 is -3. So those are the points that we will need. Now we will take all of the y's here and then move it here by multiplying -2 and add 8. So first, 4 times -2 is -8. -8 plus 8 is going to be 0. Then this one is the next value. 1 times -2 is -2. -2 plus 8 is 6. Next is the 0. 0 times -2 is 0. 0 plus 8 is 8. Next is this one. But remember, we did that already, so we should be getting a 6, right? If you don't want to have it memorized, and you can do, okay, well, 1 times -2 is -2 plus 8 is going to be 6. 4 times -2 is -8 plus 8 is now 0. So let's plot those 5 because it says we need 5 points. -7 staying at 0 is our first dot. -6 up to 4, 6. -5 up 8. -4 back to 6 because it should be symmetrical. -3 back to 0. Make sure you round out this and then go all the way. Anytime you miss your dot, just make those really big so we can see them. So there's your parabola, U-shape. We do know 2 x-intercept, so they are -7, 0 and -3, 0, right? X-intercept is when your y is 0, so those are right there. The y-intercept, we probably need to do some math, so we are going to wait. Your domain is all real numbers, or -infinity to +infinity. The range looks like it's going to be less than or equal to 8, or -infinity, students, all the way to 8, and there's a bracket at 8. Is it a 1-to-1? No. The rate of change, it is going to vary, so it varies. Increasing interval is on the right side of your axis of symmetry. Okay, so that's going to be from -infinity to, that's a -5 at that x location. Here's -5. The decreasing is on the right side, so it's going to be -5 to +infinity. We definitely have a maximum because this is the highest. You are on top of the mountain. Whee! Okay, so that's going to be a max, and the max value is 8 because that's the y value. Okay, we just have one more thing to fill out, which is your y-intercept. Y-intercept, students, is when x equals to 0. So let's look back at the original. So y equals -2, 0 plus 5. That whole thing is square plus 8. And so -2, 5 squared is 25 plus 8. That's going to be a -50 plus 8. That will end up in -42. So when you write it, it's going to be 0, -42 in parentheses. The reason it's -42 is, as you can see, it's going to keep on going, and eventually it's going to hit the y-axis all the way down the bottom, but this is the grid of 10 by 10, that's why it can't show. Example 6 says f of x equals the quantity of x minus 3, square minus 1. So guys, if you don't see a number in the front, give it a 1. So a is 1. And then h, this is a negative 3, so h is really 3. This is a negative, so k will keep its sign, okay? So vertex is immediately 3 comma negative 1. Yes, we do know the axis symmetry is x equals to 3. We do know the transformations. We only have 2 transformations because a being negative 1, students, is not a transformation. So h being positive 3, that means we will shift the entire graph right 3 units. And then k being negative 1, students, so we will move the parent graph down 1 unit. So we have 2 transformations. Let's start with the parents right away. And again, guys, parent is always the same, okay? Negative 2 for x, negative 1, 0, 1, and 2, 4, 1, 0, 1, and 4. And then transformation, a right, that's a horizontal change, guys. So what we're going to do, we're going to move the x value. Right means I'm going to add 3, and also h is 3. Now down means a vertical change, so y will minus 1, okay? So take all of the x's and add 3, just like that. And then take all the y's and minus 1, just like that. Let's try to go and get our new points. So negative 2 plus 3 is now 1. Negative 1 plus 3 is now 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Next, our y value. 4 minus 1 is going to be 3. 1 minus 1 is 0. 0 minus 1 is negative 1. 1 minus 1 is back to 0. And 4 minus 1 is 3. We have 5 dots. It says minimum 5 points, so that's what we are going to use. So 1, up 3. 2, it's 0. 3 is negative 1. 4 is 0. 5 is back up to 3. And so we are going to make our U shape. Go all the way up, something like that. X-intercept looks like we do have 2 y's that are 0. So we don't need to do any work for x-intercept. It will be 2, 0 and 4, 0. Nice and simple. Yay. Y-intercept, we can't really tell right now, so we will do some math. Domain, guys, is always all real or negative infinity to infinity. The range looks like it's bigger than negative 1, so y is bigger than or equal to negative 1, or bracket at negative 1 and it goes up, so that's infinity. It is not a one-to-one. The rate of change varies. Increasing is going to be on the right side of your axis of symmetry, so that's going to be what x value is at, 3. So 3 to infinity. And then decreasing is on the left side, so it's negative infinity to 3. Now this is your lowest point here, so that is definitely going to be a minimum, and that minimum value, the y, is negative 1. Now let's do some math for our y-intercept to check. So y-intercept, students, it's x is going to be 0, okay? So when x is 0, let's go back up to our original equation. It's going to say y equals quantity 0 minus 3 square minus 1. Well, negative 3 times negative 3, students, is really going to be a positive 9. Positive 9 minus 1 is 8. So if we were to graph this correctly, 5, 6, 7, 8, it should cross over right there at that location. So over here, that symmetry should be fine. So it's going to be 0, 8, just like that. And I believe we've filled out everything in the chart.